Okay, so we are now going to look at single displacement, also sometimes called single replacement. First thing I want to point out is to my students, the activity series is not on page 333. It is on page 272 in our textbook. Okay, so you can actually see the activity series of elements on page 272 in our textbook. But I also did put one in the resource section of your Schoology. So the first one we're going to do is lead. Lead, the symbol is Pb, plus zinc acetate. Okay, zinc obviously is Zn. You're checking the back since it's a transition metal to see its charge. Its charge is +2. Acetate, you're checking that. That's on the back of your periodic table because it's a polyatomic ion, C2H3O2. It has a -1 charge, so swap and drop. The 1 goes to the zinc, parentheses, the 2 goes to the acetate. Okay, so that is our first step. Our second step is we have to find out, is this even a possible reaction or not? So we're looking at this. We have an element plus a compound. That's what tells us we have single displacement. Our single element is a metal, so it's trying to replace the other metal, which is zinc. So we go to our activity series. Okay, let's see if I can find it. We have lead, which is right here, and we have zinc, which is in the compound. So the single element lead is lower than zinc. Since lead is lower on the activity series than zinc, we literally come over to this side and write no reaction. We don't have to worry about swapping partners. We don't have to worry about balancing the equation. This is not possible. If you put lead into zinc acetate, absolutely positively nothing is going to happen. Okay? Let's try another one. Let's try number 3. In number 3, we have silver nitrate. So silver is Ag. Back of the periodic table says it has a +1 charge. Nitrate is NO3. That's on the back of the back of the periodic table as well as a polyatomic ion. It has a +1 charge. Okay, so we have silver +1, nitrate +1, they cancel each other out, plus nickel. Okay, with nickel, since that's a D block metal, you will normally see on any work I give you the actual charge of the nickel so that you know what the charge is going to be in case you do have to finish the reaction. Okay, in this case, if you take a look at the answer key, they want you to use nickel 2. Okay, so normally you would actually see that Roman numeral 2 right here after the nickel, so you knew exactly what to use. Okay, so our single element is nickel. Let me draw my arrow here. Our single element is nickel. It's a metal. So therefore I come over here and say silver is the other metal, so nickel is trying to replace silver. So I come over here to my activity series since I know it's a single displacement problem. My single element nickel is right here. It is trying to replace silver, which is all the way down here. So nickel is higher than silver. The single element nickel is higher than the metal in the compound silver. So therefore this reaction is going to finish. So silver, which is the other metal, now goes all by itself. It is not diatomic, so it can be by itself. Nickel, we said it's going to be nickel 2. So nickel with a +2 charge is going to bond with nitrate, which has a 1 charge. Okay, so I have nickel, nitrate, 2. Nickel's 2, swap and drop. Nitrate's 1, swap and drop. Okay, at this point, you would balance the equation. I have 1 silver on both sides. I have 1 nickel on both sides. Sorry, you can barely see that. Okay, and then I'm going to keep nitrate together because the polyatomic ion stays together on both sides. So on the left, I have 1 nitrate. On the right, I have 2. I'm going to go ahead and balance my nitrates. I have 2 on the right, so I need 2 on the left. That 2 in front now tells me that I also have 2 silvers. So I have 2 silvers. 2 times my 1 nitrate gives me 2 nitrates. Now on the right-hand side, I need to balance my silvers. I have 2 silvers on the left. I want 2 on the right. So I'm going to put a little 2 there. Okay. All right. Hope that helps, guys. Have a good day.